Okay, let's continue with the subscript and indexing. So, these subscripts and indexing used when dealing with a large collection of objects, especially if they are similar. For example, let's say we have a set of, okay, here we have a set of a box of chocolate. So chocolate we have, okay, for example, like let's say we have sweets. So all these sweets are similar. The color are similar, the wrapping are similar. So how to differentiate between this one, this one, this one? We use the indexing and subscripts. Okay, let's take a look for one example. Okay, for example, set A1, A2, A3 until AN can be defined as AK, where K is an element of P. Okay, so where N is a subset of P. Okay, for example, for each N subset with P, let Dn K subset with Z, the element of Z, K is divisible by N. So when K is divisible by N, so let's say we have D1, D3, and D5. So N here is, okay, let's take a look on the first one, D1. So for D1, N here is 1. So here we can see that he said that K is divisible by N. Okay, when N is equal to 1, so meaning that it divide by 1, 1, 1, 1. So D1 is equal to dot 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 negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, if divisible by 3, D3, so you can see that dot 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 negative 6, negative 3, 0, 3, 6. If divisible by 5, so D5, dot 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 negative 10, negative 5, 0, 5, 10. Okay? Alright. Okay, next, let's take a look on set operations. So set operations, we have union, and then we have, okay, when you look at your slides, here, union, intersection, and then we have complement, and then we have difference. Okay? Okay, let's take a look on the first one, union. Okay, let's say we have A, set of A, where N is the element of N, and here is natural numbers. Okay, the element of N for natural numbers, so N here is natural numbers also, but it's less than and equal to 10. Okay, this one for the set A. Okay, where for the set B, N also element of natural number, and here it must be even numbers, and for even numbers must less and equal to 20. And then C here, the set of C also N, element of N, subset with N natural numbers here. N is even, it just stated here even only, not less than 20 or anything else. Okay, so when you list down all the numbers, you can see that A is starting from 1, 2, 3 until 10, until 10 only, because n here is natural number, so natural number we must start from 1 and it must less than equal to 10. So it stop at 10. For B is even. Also natural numbers, but even. So even starts with 2, 4, 6 until here he said that 20. This one here, 20. 20. Okay. So set B starting from 2 until 20. Whereas for set C is even number only. So even number is going to start with 2 until dot 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 dot. Okay. So the first one, try to find A union with B. So for A union with B, okay, when you draw the Venn diagram, you can see that this one is set A and this is the set B. Okay, for set A, so A we know that 1, 2, 3 until 10. B is 2, 4, 6 until 20. So the similar one, the similar A and B, you put here. So 1 here only contains an A, but B doesn't have 1. So we put 1 here. 2 also contains in B, so put here 2. 3 only contain in A, put here 3. 4 both A and B, 4 here. 5 only contain in A. 6 contains both A and B, so put here. 7 only A. And then 8 A and B. How about 9? 9 only in A. 10 both have 10. Set A have 10, set B also has 10. Okay, and then 12. Okay, because set A the last numbers is 10, so only 10 here. Okay, but B we have 10, 12, 14, 16 until 20. Okay, so 12 only contain in B only, so put here. Okay, 12, 14, 16, 18 until 20. Okay, when he said that he want A union with B, so meaning that A union with B, so all here. So the least numbers of A union with B is 1, 2, 3, 4, 5 until 20. Okay, how about A intersect with B here? A intersect with B. So if A intersect with B, so here. So the least number of A intersect of B is 2, 4, 6, 8 and 10. Okay. Okay. And then what is the symbol of this one? Slash. So here the symbols refers to difference. So meaning that difference here is when you see your slides, okay, it contains in A but not in B. So A difference with B, when you look at your Venn diagram, here only. contains in A but not in B. Okay, so that's why A different with B is 1, 3, 5, 7, 9 only. Okay, but B difference with A, for B different with A here only. Okay, so B different with A is 12, 14, 16, 18, 20. Okay, the last one, this one, the symbol, this one, all together. So all. You see 1, 3, 5, 7 until 20. Okay. So this is set of operation. Okay, let's take a look on another example. Okay, we have the second example. Same with this example. We still use this number, B, C, but this one, the example is A union with B. But this example is about B and C. So for B and C, okay, when you draw the Venn diagram, okay, you can see like this, B and C. So B union, B intersect with C. So here only. Okay. Okay, how about B difference with C? So B difference with C, so here. So doesn't have any element, you just put empty set. Okay, for C difference with B, here. Okay. Okay. Okay, the last example altogether, A and C. Yeah.